So if you need to find a derivative of a function that can be composed of other functions inside of it, with composite functions, then we need the chain rule to find a derivative. And what a chain rule says is that you evaluate the derivative of the outermost function. In this case, the outermost function would be a cubing function because of that 3 on the exponent. You take a derivative of the outermost function and then keep the innermost function the same inside. So just in case it's the first time you've seen it, if this was our function, all you have to do for the chain rule, if you're trying to evaluate the derivative with respect to x, the chain rule would be h prime of f of x. So it's a derivative of the outermost function h, with the innermost function kept the same, multiplied by a derivative of the innermost function. So here, h of x, if we're trying to evaluate that derivative, then we need a derivative of the outermost function, the cubing function. So the derivative of the outermost function is 3 here. Now I'll scratch this out because it's not the same f of x. It's going to be 3 with the times the it's the innermost function kept the same, but it's now going to be squared using the power rule. So I took a derivative of the outermost function, that cubing function, kept the innermost functions the same, and now I multiply by a derivative of the innermost function. So now I'm ignoring the outside function. I'm just looking at f of x divided by g of x. And if I try to evaluate that derivative, I need the quotient rule. So it's a derivative of f of x, the numerator, times g of x kept the same, subtracted by f of x, times the derivative of g of x, derivative of g of x. And that's all being divided by g of x being squared. Okay, we're done. We have the derivative with respect to x. Now they want us to evaluate the derivative when x equals 3. So that means you just need to go through the function and plug in 3. So f of 3, if I was to plug this in, the notation would look like this. So if I plug in 3 for x, then f of x equals 3. So this is going to equal 3. And then here, g of 3, if I plug in 3 in for g of x, the table tells us we're going to have 1 for a value. It doesn't tell us what g of x is, but it tells us if you're to plug in 3 for x, the function would spit out 1 for y. And then f prime of x is the derivative of x, a derivative of f with respect to x. So that is 3 and times g of x, original g of x, not g prime, according to the quotient rule, minus f of x when you plug in 3, so that's 3, times the derivative of g, which is 2 when x equals 3, all over g squared. So g at 3 is 1. That's being squared. And now the rest is just simplifying plain old numbers, right? So 3 divided by 1 is 3. 3 squared is 9. 9 times 3 makes 27. Oopsie daisy. And then over here, 3 minus 6 makes negative 3. Negative 3 divided by 1 makes negative 3. So this is 27 times negative 3. So it looks like negative 81 is our answer. This one's a bit trickier because of the x that's being multiplied on the inside. So let's write out with notation what h prime of x is, the derivative of h. It's the derivative of the outermost function with the innermost function kept the same, multiplied by a derivative of the innermost function. That requires the product rule because this is a function of x. It's a boring function of x, but it's still x times a different function of x. So we need the product rule. The derivative of the first function, derivative of x, is just 1. Times the second function kept the same, plus the original first function times the derivative of the second function. Okay, so if they want to know what h prime of 3 is, that just means we're supposed to plug in 3 into the derivative. So everywhere where we see an x, I'm putting a 3 in its place. So this is just, I'm just going to put f of 3 here because it's just times 1. Okay, So we got to figure out what this is before we can say what this G prime term is. So f of 3 means you plug 3 in for x, so we get out 1. 3 times 1 makes 3. Then over here, f of 3, we already found that, it's 1. And then f prime of 3, that means we plug 3 in for f prime, so that gives us 4. And then g prime of 3, they have it from the table. That value is 2. And then 4 times 3 is 12. 12 plus 1 makes 13. So we get 26.